All right, well, this chapter, we're going to be covering chapter 3. I know it's kind of weird, we're going backwards, but you'll see why. Chapter 3 is all new material. It's kind of in depth. So that's why chapter 3 is done at the beginning of the second semester instead of the first semester. As you'll see why by this first video. So we are starting off something called U substitution. U substitution is used to solve for x when x looks crazy. For example, let's take something like this. Let's say x squared minus 4x minus or plus minus 32 equals 0. Then I said solve for x. Well, if you solve for x, you just factor this. X minus 8 times x plus 4. And then your solution is x equals positive 8 and x equals negative 4. Super simple because we know how to factor. Well, U substitution assumes you know how to factor and you understand that concept, but you have to do a couple more steps. But conceptually, it's a trip because U substitution will always work. You're going to use U substitution for those of you guys that go into calculus. You're going to do integrals where you have to do U substitution. You don't really see it too much outside of integrals with calculus. But let me kind of walk you through. In the notes it says you can use substitution. You can use U substitution to make an equation easier. And I give you a crazy looking equation. I say this: x squared minus 5x. But I say this whole thing is squared minus 4 times x squared minus 5x minus 32 equals 0. And the question is solve for your x. So if you were to do this, this becomes crazy because you'd have to expand this out, group by factoring it, and it's gonna be crazy. So there's an easier way to do this, and it's called U substitution. So notice I have the same thing right here and right here. What I'm going to do is I'm going to kind of suck both of these out on the outside, and I'm going to replace it with a variable called a U. U is, you can replace it with any variable, but conceptually they've always liked to use U. But I'm going to say, I'm going to plug a U in here and then a U in here. But I know, look, if I get rid of this and I get rid of this, I know, and I replace it with a U, I know that U actually equals what I got rid of, x squared minus 5x. So now I'm going to leave this on the outside, and I'm not going to even worry about this right now. And I'm going to solve this just as it is normal. I'm going to get rid of the parentheses. I don't need the parentheses anymore because I just replaced this with a U. And I'm going to go ahead and solve this now. This is exactly like the question that I just said. If you were to factor this would be U minus 8 times U plus 4, because two numbers that multiply together to get negative 32, add together to get negative 4 equals 0. And then if I solve for this, I'm going to get U equals positive 8, and I'm going to get U equals negative 4. These are my two solutions for this equation. That should make sense to everybody. Okay, but this is the thing. U is actually equal to this. This is what U equals. So U substitution says, you know how I pulled this out in the beginning? I'm going to actually take this and plug it back in. I'm going to substitute it for what it equals. So instead of U, I get x squared minus 5x. Instead of this U, I get x squared minus 5x. And now you have two equations that you can solve for. So you're actually going to have 4 different answers. Once you substitute the u back in, you just solve for this. This is a quadratic. So you're going to subtract the 8. X squared minus 5x minus 8 equals 0. You're going to have to use quadratic equation for this to get 2 different solutions. And for this, x squared minus 5x, you could add that 4 to move it over, plus 4 equals 0. You would have to use a quadratic equation for this. But for this, you can factor. This becomes x negative 1, x negative 4, because negative 1 times negative 4 is positive 4, negative 1 plus negative 4 is negative 5, giving you a solution of x equals 1 and x equals 4. You're going to have 2 solutions. The first solution is going to be 1, or the first 2 solutions is 1 and 4, because this one was very simple to solve. This one, you have to use a quadratic equation. So you have to use a quadratic equation. You're going to have x equals something. It's probably going to be some weird looking thing. And x equals another term. So you're going to have 4 solutions to that first example question that I gave you. So for u substitution, what you're doing is a couple steps. The very first step, you have to figure out what you're going to substitute for the u. Second step is factor it and solve. Third step is plug the substitution back into the u. So what I'm going to do now is this. I have another one that I'm going to put up, m minus 8 square root of m equals 20. And the question is, what number minus 8 times the square root of that number equals 20? So it might seem like it looked like a pretty simple question, but it actually gets a little more in depth because it's hard to figure out what this number is unless we figure out what we're going to substitute for u. So you have to figure out, what can I substitute for u? What is u going to equal? Think of it like this. What number squared gives me m, and then the number by itself gives me root m? And it's actually, if you look on the notes, I say we're going to use u as the square root of m. Because look, if I do the square root of m squared, I get m. If I just do the square root of m, I'm left with just that number. So I can substitute this m for a u squared, because square root of m squared is your m, stays the same value. And I can substitute u for the square root of m. Now check this out, much, much easier. Look, u squared minus 8u minus 20 equals 0, and then solve. So I'm going to factor u minus 10 times u plus 2 to get u equals positive 10 and u equals negative 2. Okay, cool. So these are my 2 solutions. Now, I'm going to take this and substitute it back. Boop. Take it and substitute it back. So instead of u, it's actually the square root of m. Square root of m is equal to 10, so I would square both sides. And I'm going to get, one of the answers is going to be m equals 100. That's for this. Let's see if it works. My original question was m minus 8 times the square root of m equals 100. So if I plug 100 into here, 100 minus the square root of 100 is 10. Is that equal to 20? Yeah, 100 minus 80 is 20. Yep, that works. Cool. Okay, now my next one, I'm going to substitute the u for what it equals. It doesn't equal just u, it's actually the square root of m. Now look, this is called an extraneous solution. The reason why is because whenever you have a square root, you can't have a negative answer. So technically, this will not give you an answer because you can't square root a number to get a negative answer. There's only one solution, which is m equals 100. Okay. Next question that I'm going to give you is not from the notes. This one's going to be a little more difficult. Now what I'm going to do is I'm going to write it up here, but what I want you to do is pause the video and see if you can figure out what you're going to use for u. I'm going to say 3 times square root of x plus 1/4 equals, oh, let's do this. Make it a little easier. Let's do this. Let's keep it simple from the last question. P minus 12 times square root of the same number is equal to a negative 35. Pause the video and see if you can solve for P. All right, if you pause the video, first step you should do is you should substitute P for a U. And the safe bet is what? Think of it as ax squared plus bx plus c. We're going to move this over later on. But what number squared gives me p? What number squared gives, or what number by itself is root p? Well, that's the answer, is square root of p. This is what I'm going to use. Now I'm going to get rid of this p and make it a u. I'm going to get rid of this square root of p and make it a u, because I know that u equals square root of p. And I'm going to rewrite this as a quadratic. This is u squared. U squared minus 12u plus 35 equals 0. So I have u minus 7 times u minus 5 equals 0. That should be pretty easy. This is going to give me u equals 7. This is going to give me u equals 5. All right, good. Now, u is actually a substitute for square root of p. This is actually a substitute for the square root of p. Okay, now here's your two equations. What number square rooted gives me 7? One of the solutions is p equals 49. What number square rooted gives me 5? The other solution is p equals 25. Those are your two solutions. So once you substitute u back into it, there's not a same pattern that you're going to use to solve. You just have to look at your new final equations and solve for that variable. Okay, the last one I'm going to give you, this is going to be the last example question. So with this, I'm going to be asking you Alright, so here we go. Here's your equation. Now what I'm going to ask you to do is solve by u substitution. So this is going to get a little tricky in a second. But first off, you got to figure out what you're going to use for your u. If I have these two are the same, but this is squared, I'm going to say u is equal to q squared minus q plus 100. So since I have this, now I can substitute this quadratic for what it equals, which is u squared. I can substitute -3 times this quadratic. I can substitute it for a u, and I can move this over. So I'm going to say u squared minus 3u minus 1 equals 0. All right, now I have to solve for this. I have to solve for my u. This is not factorable because you can't get two numbers that multiply together to get the c and add together to get the b. So what you have to do is you have to use a quadratic equation. So with the quadratic equation, I'm going to set it up is u equals negative b plus and minus the square root of b squared minus 4 times my a times my c, all divided by 2 times my a. All right, now let's just simplify this real quick. This is STEM, so you guys could probably do this pretty simple. While I'm doing this, I have -3, 9 minus 4 times 1 times -1 is -4. 9 plus 4 is 13. 2 times 1 is 2. All right. And then, this isn't your answer though. You're going to have to actually create two different answers for this. All right, so with this, I'm going to get my calculator out, and I'm just going to estimate the square root of 13, which is going to be square root of 13. Let's just round to the first decimal and say 3.6. So 3 plus 3.6, 6.6 over 2. And 3 minus 6.6 is negative 0.6 over 2. I got to find my two answers. 6.6 divided by 2 is, 6.6 divided by 2. It's going to give me 3.3. So I have one of the answers is 3.3. For this one, negative 0.6 divided by 2. It's going to be, my other one is u equals negative 0.3. These are my two solutions if this was an IM2 class and I said solve for the solve for the variable. Well, now, unfortunately, we're not done because we actually have two more equations to solve. See this 3.3, I'm going to substitute it for the u. So I'm going to have 3.3 equals q squared minus q plus 100. I'm going to substitute this negative 0.3. Negative 0.3 equals q squared minus q plus 100. Here's my two equations. Now I would use, you guessed it, quadratic equation again. But before I use a quadratic equation, I have to move this over, I have to move this over, and then solve. So sometimes you're going to have to use a quadratic equation, unfortunately 4 times, to figure out this solution.